So thanks for coming out on Halloween and Dark Matter Day. Dark Matter Day was organized by Fermilab. We'll talk about that later, but let's get started. So what's going to happen here is we're going to go through some history really quick. What is this? Some people don't even know what we're talking about. Some people are really well versed. So we're going to kind of cover all the bases really quickly. We're here to give you a feel for it and then go from there. So you remember the talk was titled "A Terrifying Proposition: Is Dark Matter Hydrino Energy?" So that's the topic. So this all starts, let's put a date on it, in 1989 when a scientist named Randall Mills made a leap in science. And he didn't start in 1989 or even 1979. He went back to the 1920s. This photos of some of the premier scientists of the day. You can see Albert Einstein in the front row, and you'll also see Dirac and Schrodinger in this. So he went back to that era and looked at things from a fundamental point of view.
Now, is this time travel, Naveed, or are we speaking metaphorically here?
All metaphorically, yeah. Unless there's a universe where that's possible, he couldn't have done it. So,
topic for a different podcast, maybe.
Yeah.
Just kidding. Go ahead.
So the electron in quantum mechanics today, if you go to MIT, you'll learn that it's sometimes a point. Fundamental particles are a point, and sometimes a wave. That's conventional thought of the last 100 years. So he was addressing something fundamental. And what he said was this: perhaps the electron's like a bunch of grid copper wires, superconducting. So it's not per se copper, but just let's suppose you twist them around and around and around and around in a sphere, at least in the hydrogen atom. And what are you going to get? What's going to happen with that kind of a model? So he's doing a physical model. When he did that, he found that the resultant solution had something called spin, that these electrons spin. Let's call it like a ball would spin for ease of understanding. But not only that these wires, when they're conducting, would generate a magnetic field. And that was interesting because we know that electrons spin and they have magnetic fields. They're kind of like bar magnets. And you can create a magnet from current through copper wire, and you twist it around, you're going to get a bar magnet, basically, with a field, a north and a south field. So he's kind of addressing something really simple and fundamental, which is, how can these electrons seem to behave like little magnets, and why do they spin? And why isn't no one else thinking about this? This must have been what he's thought. So he was probably excited. This is Dr. Mills, Randall Mills. And eventually he worked this all out and went to discover new things. And so, like anybody, he was wondering, what would the physicists of today think? And he was pretty open about what he'd done. And he was met with horror. This was either going to be really a breakthrough for the field, or it's going to be very scary because it was a huge change. So he had to work within a circle of trust, and he'd learned some things from a professor at MIT when he was at MIT named Herman House. And he went to him and said, look, I did it. Like, this is so fundamental, this understanding. And when he did that, what happened? Herman House at MIT, electrical engineering professor, and he's a decorated professor at MIT. He's no longer alive. He said, I can't help. The quantum theoreticians will try to destroy me. And so, in this concept of Star Wars, if he's Luke, he's going to his father and he's like, nope, I'm not able to support you. So what was happening? And you're going to see, if you've researched this topic, or even if you haven't, you will see that there's been a lot of pitchforks, knives, and a lot of clarion calls saying this is impossible. What you're going to see in today is impossible, and this line of thinking is not valid. And we've kind of scratched our, racked our brain for what is this? Why is this happening? And what it turns out, and this is going beyond a little bit the physics, but let's do that. This turns out that when you challenge someone's worldview and they're entrenched, they're gonna react. That's gonna cause a reaction because you're changing that. You're saying that reality, that the way that works today, what you think, what you've thought maybe your whole life, is not exactly correct. And what one of the tactics people use to kind of suppress and effectively when they're experiencing cognitive dissonance is called gaslighting. So what do you do there? You discount information. So these new ideas are, they're put aside. Use verbal abuse in the form of jokes, and you block and divert attention from outside sources. So, for example, some people know that even some of Dr. Mill's patents were challenged to divert and block that attention, and effectively from the patent office. And I think it was the only time in history when a patent was revoked after being accepted, and that was done by a professor that you can hear about again. So that's one way to hear about it. So what was going to happen next? What do you think was going to happen next? Now we have kind of the rise of a new concept, of new theory. It needs to be validated, needs to be looked at. What do you think was going to happen next? Well, it could only mean one thing, that blood was going to have to be spilled. And so Stephen Chu, extremely unlikely. Robert Park, this is bullshit for shallow brains. And that was a very strong directive. Do not look here. And so we know in history, this is not the first time this type of thing has happened. This is a art of Galileo in his prison cell. And he's even drawing on the floor of the cell. And so this is like the dark nights of the soul, effectively, right? Like you are now isolated from your community, from others, from people. And that's probably what Dr. Mills felt like. Must have. That's what was happening. And so he had to transform. Basically, he had to go on his own path. Now, he wasn't locked up, right, physically, but effectively he was. He wasn't persona non grata in his community. He didn't have access to the best thinkers in the field, and so he had to do a lot of this by himself. But he had a jewel of a new idea in mind, and the physics that he'd come up with helped him to predict and start to experiment with a new idea in terms of a new energy source and a new state of matter. So he predicted, and he came up with the math and the physics to show that it's possible that hydrogen, which has one electron, and now you know that he knows what an electron is, has another smaller form. And he called that the hydrino. So it's just another state of hydrogen, or an allotrope of hydrogen. And that was interesting, not just because it's a new realm of chemistry, but also because it meant that if we could move electrons around, that being chemical energy, this would be one of the most powerful chemical reactions we have. How powerful? Well, when atomic hydrogen goes to hydrino, the red going to the blue, going to a smaller hydrogen, that would release, in some cases, 100 times more energy than burning that hydrogen. So this is a new chemical reaction, a new state of matter, a new chemistry. This is new, and I won't get into how it works, but it's a new catalytic chemical reaction. So this is a lot of new stuff that had to be explored. And so that isolation wasn't bad because it allowed him to explore, as a private company in New Jersey, this new chemistry. And we won't be able to cover the twists and turns of that tale, but as you know, Brett Holverstadt on my team wrote a book called Randall Mills in the Search for Hydrino Energy, and that covers that kind of intertwined business and technical and physics tale, and it's a great book. But even in 2009, even after at least 80 to 100 articles on the subject by 2009, I think it was even 100 at that time, this is still nonsense. Right? Still the blockage. There's no state of hydrogen beneath the ground state. And this is at MIT. And so it was left to make this explosive, something impossible and overwhelming, right? Like it has to be overwhelming to the senses. And then in 2015, explosive and sustained hydrino reactions. And then in 2017, plans for a product with a Berkshire Hathaway subsidiary called TMI Climate Solutions. And then in 2018, you see this extreme bright plasma cell called the sun cell. And so these are hydrino reactions producing light that no other chemical reaction with hydrogen we have could do. So hot they could actually burn through metals, but this still being impossible. Today, as of today, at Brilliant Light, one of the Hydrino Energy companies, in calorimetry testing, they have a reactor that produces at least 100 kilowatts of energy. So already competitive with fossil fuels and the internal combustion engine, and then we'll eclipse it. And we have widespread worldwide replication of hydrino energy. There's individual researchers, young researchers coming up. There's hydrino products in the field. They don't go by that name, but they produce heat that couldn't be explained by any other chemistry. And we have hydrino products in development around the world. So now we ask to kind of get to the heart of the matter and the interesting part of this. We know hydrino energy is real. We know this is real physics. And this is revolutionary physics. So we want to ask the question, is dark matter, is hydrino itself, that new state of hydrogen, dark matter? And so I'm going to hand it off at this point to Brett to take this part of the story forward.
Yeah, so I mean, in short, it seems like it is a very good candidate for dark matter for a couple of reasons. One is that it's hydrogen, and most of the universe is hydrogen that we can see. Upwards of 90% of visible matter is hydrogen, and it's either, trapped in stars, or it's in these vast galactic and even intergalactic clouds and halos that surround galaxies. The next really fantastic reason is that hydrinos, they're hydrogen, but they don't emit light in the same way that hydrogen does. So typically, if you shine light on hydrogen, the electron will jump up to an excited state, and then it will quickly decay back down to a lower state, and it'll emit a photon of light within a specific range of frequencies, or a specific frequency. And when we look in these large clouds of hydrogen gas in space, we don't see light being emitted by dark matter. And so it was predicted to be this way by Mills, by his electron model, that hydrino atoms would not possess excited state orbits at all. As a matter of fact, they're trapped on this ladder of potential stable orbits, but those orbits below the ground state actually can't possess excited states. So you really only see these hydrino atoms when they're being created or destroyed. You can't see them just there in space. So it's one of the only forms of matter that we're aware of that really doesn't radiate. And the only other options are there's a molecule H3+, which will actually dissociate before it will actually produce an excited state orbit. So it's extremely rare and extremely unique to have a kind of matter that doesn't radiate, but this is exactly what we're looking for with dark matter. There is
to the sun.
Sorry, go ahead.
The next slide will have the sun. Do you want me to, or we'll be talking about the Anderson and then the sun? So let me know when you want to advance, but keep going.
Sure. So those are two very good reasons, and there's a very good chance we can go ahead and move forward into the sun slide. There's a very good chance that not only was dark matter there before the sun existed, and that potentially the sun and many stars are formed partially from dark matter, but that these hydrino reactions are occurring in the sun itself. And as Philip Anderson, I love this quote by Philip Anderson, because he's grasping the fact that if you could fuck around with a hydrogen atom, you could fuck around with the energy process in the sun. And that's certainly true. And that we see spectroscopic lines from the sun that have no other assignment but match pretty well Hydrino emissions, predicted Hydrino emissions. And we know there's an energy imbalance in the sun, so there's a significant amount of the sun's power is unaccounted for by the neutrinos that are being emitted by the sun, which are produced by fusion. So if some percentage of the energy coming out of the sun is not fusion, well, maybe some of it is being produced by these Hydrino reactions. And the closer we look at the sun, the more likely this is to be true. We see these very small but extremely bright releases of energy on the sun's surface, which look very, very much like the reactor cells that Mills is producing in the lab. Brilliant white light emissions that are very localized and extremely energetic. And these small flashes you can't see on this scale, but as you zoom in much closer to the solar surface, you start to see them. So it also explains, Hydrino reactions are also likely occurring in the atmosphere of the sun, which could be the source of coronal heating, up to 1 million degrees in the atmosphere, but only 6,000 degrees on the surface. So there's a lot of things happening there that could very well be explained by Hydrino. But if you want to move forward to the next slide, we can kind of take a look at some of the dark matter images that we see in space.
Sure, absolutely. Let's move forward then.
So this is, we see evidence that light is being bent by dark matter, but we can't see the matter itself. And this is a kind of, it's an image that was artificially produced. Everything you see in red is more traditional matter that we can tell is there, and everything you see in blue is dark matter. And so we can tell that it's there. We can tell it's bending light, but we can't see the source of, we can't see the mass that's the source of this bending. So here's a case where it's like, well, why do we see dark matter in the halo around this galaxy cluster? This is the bullet cluster, but we don't see dark matter in the center. And there's a couple possible reasons for that. One reason is that the dark matter in the center of the galaxies, or in the center of the galaxy cluster, is actually being depleted because it's forming stars. And as soon as it becomes massive, dense enough to condense into a star, obviously we can see it at that point. But there's another possibility here, which is that when galaxies are colliding, that dark matter, if it's hydrino hydrogen, it's potentially much, much, much smaller than traditional gas. And one could argue that it more easily transports itself to the outer regions of galaxies and galaxy clusters because it has a much lower collisional cross-section. It's not going to interact very much with other gas that it's passing through because it's so small. And so you're more likely to find it on the halos. And the next slide, you'll see this too. You'll see these rings of dark matter that are in the halo around galaxies. And this seems to be the case, that it tends to congregate and remain in these large clouds on the outside edge of galaxies and form a large halo outside the center of galaxies. And I feel that is all very consistent with the idea that hydrino hydrogen is dark matter. And in addition to that, there's still other evidence too, which is that these clouds of gas that we see out there are very warm, very, very unexpectedly warm. And they're emitting in weird frequencies that we would not expect to see in a cold gas cloud. So some of this is explained by hydrino reactions taking place over time and releasing heat into the clouds, warming the clouds as a whole, and very specific spectroscopic signatures from hydrino emissions when they're being formed, that we see those signals in space. And then when you look at the entire universe, all of the galaxies, if you look at emissions produced by hundreds of galaxy clusters, and we kind of stack all that spectra and try to get a higher resolution view as to individual signatures, we see unidentified lines, particularly in the X-ray, the soft X-ray region, that correspond almost perfectly to hydrino emission lines. And so I think that the scientific community is slowly getting closer to finding it and maybe even predicting that it's some form of hydrogen, some form of cold hydrogen. And some researchers are predicting that it's potentially related to the things happening in the solar corona on the surface of the sun. So I think as the scientific community continues to research the phenomenon, some of the researchers are starting to get closer and closer to this idea that it's some kind of exotic form of hydrogen. And so that's really exciting to watch. It's kind of like watching a small child, learn to use a spoon. We have the answer, but we're kind of waiting for everybody to catch up slowly and taking their time.
Oh, that's good. In terms of the spectroscopic evidence, I guess the question I would have is what's the most telling, do you think? Is it the stuff that they do in the lab when they do these energetic reactions, and then what is the telltale?
Yeah, so I think I was most convinced by the extreme ultraviolet light that we see in space. So there's really not a lot of good sources, prevalent sources for extreme ultraviolet or EUV light. And some of those signatures we see in space have been observed at sometimes with like sounding rocket, with telescopes, EUV telescopes on sounding rockets. But then that hasn't been observed other times. So the data is a little inconsistent. And some of the data for these specific lines we see have other potential interpretations. They could be extremely hot emissions from iron or oxygen. So they're not 100% convincing, but they're a pretty strong indication, I think. And then the evidence that Mills is seeing in his reactor cells, he's seeing very specific emissions in the extreme ultraviolet, and some of these signatures correspond to the ones we see in space or in the sun. But he's also able to produce, just the fact that he's able to produce extreme ultraviolet radiation from hydrogen consistently is extremely encouraging, because when we look out into space, we see extreme ultraviolet light and we can't identify the source in all cases. There's a lot of EUV emissions out there. It's way more than what was ever predicted to be possible. And when you combine it with this other evidence, it makes it even more likely that this is a good candidate for dark matter.
That's excellent. We're almost at the time we wanted to cover. I know people would probably like to hear a lot more, and we'll have to do more of these. I guess the things that I would add to what you said was that, there's been widespread replication. Like I think I've found, having been on many, having talked to even many researchers in the field, which sometimes even goes by the name LENR, but you'll find they're working with hydrogen and catalysts that are hydrino catalysts. Even those researchers in some companies, they actually, when you really probe, they actually haven't read the journal papers. And so you ask them, have you read this paper? Like, oh no, could you send that to me? I'm like, well, it's under a paywall. Usually you'd get the journal, right? Because it's your field. You're researching or you're building product. You probably want to know about that, and they haven't actually read the work. So you probably be pretty stunned at the inefficiency of people, both who don't want to look, which is a lot of the dark matter researchers, because it's just challenges a lot of areas that they've come to accept as foundational, right? They kind of work on top of, they don't go back and question premises. And then also the people in the field who are experimental, they kind of don't even care. They're like, let me get something working. So that's kind of an interesting finding from myself. I don't know if you have anything to add there, Brett.
Not particularly, no.
Okay. Well, I guess I would just say that the event that you just went to has not been approved by Fermilab or any dark matter researcher. In fact, this event was approved, and then quickly, and you can see the third line there. So I basically sent email, we've submitted an event for dark matter today. I don't see an invite on the website. Can you advise? And then we got an, oh, your event's been approved, right? We had to kick that into action. And then pretty much a little while later, this event is not appropriate and I am removing it. So this event was shot dead by somebody. We don't know who that is. We then followed up courteously, said, hey, look, there's 100 papers and 30 years of science here, and here's a list of those papers on a website. Oh, by the way, the U.S. Department of Defense affiliated labs have stated that this energy exists. So that's not under question. However, our subject should be looked at, which is whether this maps with whether this hydrino atom maps to dark matter and the merits of that thesis. Happy to discuss on the phone, and no further reply was received. So that was unfortunate. So that's the end of our discussion today. It's a dark and interesting subject. And thanks for coming out. And just to know, we're End of Petroleum. We're kind of really advocates for this energy and what it can do for the environment and climate, and also the breakthrough science that's behind it. Thanks so much, everybody.
Thanks, Naveed.
Thanks, guys. Bye.